about Groovy. That's okay. All right. Thank you. So welcome back, guys. Hope you have had a good time so far at DevBox. We still have half more a day and 2 more days of fun, so make the most out of it. Today, I only have 50 minutes to talk about Groovy, and as you just heard, I can talk about Groovy for hours. Why? Because I love the Groovy. The topic for today is functional Groovy, and I guess that is it okay to say that half of you are already comfortable with functional programming? Is that a right assumption? Okay, because the other half, let me tell you, if you're not, then if you were at the keynote, now you know that once JDK 8 comes out, we will be thinking in a functional way, whether we want it or not. So it's better if we get into this mantra that functional programming is not really that bad. But as we wait for JDK 8 to be released, we can branch out to other JVM languages and try out those functional constructs. So this is the reason why I like to propose Groovy, because Groovy is kind of like a mature language. It's 10 years old. Let's see some hands. Who uses Groovy already? Oh, wow, pretty much almost everybody, 80% of the room. That's perfect. Awesome. So you know Clojure. So I'll go around this talk much faster. And this is kind of a 60-minute talk condensed in a 50-minute talk. So here is boring stuff. Okay. Usually when we think about functional programming in the JVM, these 2 languages pop up into mind. Either it's a Scala if you're in a static type mode, or if you go Clojure, which is fully dynamic mode. But of course, my proposal is do this. And for some that are not used to Groovy, this is the next thing that pops up to mind. Really? Groovy is a dynamic language. Groovy is slow. Groovy is OO. Groovy is not functional. Groovy has this and this and that. So, yes, I know. But if you follow certain guidelines, then you can write functional in a functional style using Groovy. But there's one thing you must remember. Groovy is not Haskell. If you're looking for a pure functional language, you will not find it in Groovy, you will not find it in Clojure, nor in Scala, nor in other ones. There are 2 other options for you if you want to do this. One is called Haskell, and the other called Frege, which is kind of like an implementation of Haskell in the JVM. Anything else is not purely functional. But let's get that out of the way. So you said you guys mostly know Groovy, so you know these closures are kind of like functions if we want to be a little bit lenient with the nomenclature. The first version of how you can call these closures, how you do it in Groovy. If you want to call closures from Java, just make use that you execute the call method. And that's it. There is no magic whatsoever. In our closures, we have access to the outside environment. And this is one of the things why these closures are not side effect free, they are not pure functional, because in this case, the example that you're seeing, we have access to a variable that has been defined outside, then we change it inside the execution of a closure, and then when we check the value again, surprise, surprise, the value has changed. Sometimes you want this to happen, it's great. Someone say that when you're doing UI programming, some things might leak out and you want to do this kind of stuff. For some others, be careful about these side effects. In Groovy, you can also have no types. If you don't want types, don't use them. If you need those types, put it there. So it's the same thing whether you put types or not. You can still call these closures in the same way. You also have default parameters. You might have seen this feature coming in other languages, for example, PHP. Who here has PHP experience? I have no problem saying on record that I did PHP in the past. And yeah, there are still some psychological issues with me, as you can tell. But that's okay. Default arguments, they work perfectly well with closures. In this way, then you can invoke functions with less parameters and have those arguments that you had not specified already have some value. If you do not define an argument, and this only works when a closure may take one and only one argument, then you have already one supplied to you, and that one is called it. So those 2 closures that you see there are functionally and behaviorally equivalent. If you need to define a function that takes no arguments, then you have to use the other notation. You see there's the arrow, and there are no arguments previous to that. Now that we have functions, then we can talk about more things. So for example, of course, iterators and streams. We'll get streams in JDK 8, partial evaluations, we call them coring, composition, memoization, and perhaps tail call optimization. Iterators, you will see these things coming in JDK 8, but we have had these iterative methods already coming in the what we like to call the Groovy development kit, GDK for short. So basically what we're doing is enable you to pass functions to methods that know how to go from one end of a collection to the next one. So you are no longer concerned about how the iterator, or well, how the collection gets, how you traverse the collection, but what you actually want to do with each one of those elements. So here I have a couple examples of things that you can do. You can find all elements or find just one. So whether this thing is hidden, of course it could be done in a different way. Right now it's doing it in an iterative way. But what if this was done in a parallel way? Well, I have a slide for that, and you will see that it's simply calling the same method. There will be another thing in there. Or you can find all elements that match a condition, or just the first one that matches a certain condition. Is up to you. Here are some other examples that are closer to how we usually think in functional programming. So we can take the n elements from the head of the collection, or drop the first n elements and then grab the rest, or just the head, or just the tail. We can compose, we can collect, we can get all the permutations, combinations. There are plenty of iterative methods that accept functions on collections. There is kind of like a classic naming for these operations. In standard Lisp or the other functional languages, you will find that the names are filter, map, and fold, or even reduce. In Groovy, we use different names. It's final, collect, and inject. But because of the runtime metaprogramming capabilities that Groovy has, we may be able to create some aliases for these things, and I'm going to show you in just a moment. Now, I have encountered these two guys previously on another conference, and they presented kind of like a functional showdown within Java-based frameworks for functional programming. They presented functional Java, Lambda4j, and even Google Guava. So they have a couple of scenarios how to, now that you have a list of beers, because, hey, we like to drink beer at the end of our long working week, perhaps we would like to know what was the cheapest beer that we consume, what is the most expensive, what is the name of the most expensive, let me get the name of all the beers, and finally get me the total of what we paid if we were really, really happy and we didn't remember. So they presented each one of these scenarios, which one of those frameworks, and I asked them permission to do the same thing with Groovy, and I came up with several solutions for each one of those scenarios. Why? Because one great thing about Groovy, and you guys may already know this, is that you can write Groovy in a very Java-ish style. Pretty much you can replace .java files into .groovy and compile it with a Groovy compiler, and it works. Or you can go all the way to the other spectrum and write in a very idiomatic way. So whenever you are, if it's one on the other end or somewhere in the middle, you will find some piece of code that actually talks to you. So here's my example of grabbing the cheapest beer. The first one is perhaps what, if we are very used to thinking in an imperative way in Java, say, well, we have to iterate over each element, grab the price, and then sort them out so that we have the smallest one at the top and then the biggest one at the bottom, and then grab the first element. So the three first versions are pretty much that. Now, what I like really nice about Groovy is that you have this kind of higher order functions. So I can send this function to the min function, and this will locate the object that complies with that condition. And if I have a beer object, then I just do property access and grab the price, and I'm done. Conversely, finding out what is the beer that is the most expensive one is just inverting that condition. So we can do it in this way. So now that you have sorted out, you can get the last or reverse, So now you got the max at the top and grab the first index, or you just use the max function and give it another function, and that's it. Grabbing the name of the most expensive one. The first version looks very Java-ish because what we're doing is we're computing, we're trying to get the value of the most expensive price, and based on that price, then we find the element, and then we just grab the name. Now, this is a clear example of a not side effect-free function because we are affecting our variable, the variable max, that lives outside. Or we can just use burst max at IT price and grab the name. Computing the name, the list of all names, there are several versions. My favorite is the last one, which is, some of you might recognize this as GPath. So think about XML and XPath. Now forget about XML. You apply GPath to an object graph, and you navigate every single object, and you can do this. This is basically Groovy instructing the beer list to grab the name property of each element and put those names into a new list, and that's it. Much simpler than doing the standard way. Finally, the last example. Well, I can use sum and give it another condition. I just want to sub the prices. I don't want to sum the beers. One great thing about Groovy is that if I overload the sum method on my beer object, then I can do the sum on all the beers in this list without explicitly saying I want to sum them by the price. So it's up to you. So now that we have these examples going on, well, they actually presented some pros and cons against each one of those frameworks. The pros about Groovy is that you're using the standard Java collections. So if these things in the future become parallel aware or somehow magically have much more features coming in the future JDKs, then you will have them immediately. You don't have to relearn, you don't have to have a special bridge within one kind of collection to the other. It plays very nice with other functional frameworks, and of course you have metaprogramming. The disadvantages is that these methods are not lazy evaluated. The streams are not included in core, and of course the names, whether you like filter, map, reduce, or final, collect, and inject, it's up to you. Remember that I said something about metaprogramming? If you really want to have those method names, filter, map, and reduce, use metaprogramming. And in that way, you can create method aliases and then call it as if those methods were already defined by the GDK. There's no problem. Streams. There will be streams coming in JDK 8. We already have streams in Groovy. This is an external extension maintained by one of the core Groovy developers. And basically, the first example is creating an infinite stream of elements whose value is 1. And the second one is creating a stream from out of a range. So it actually is a limited stream. And it's filtering those out by if they are even or odd. And when you collect on a stream, you transform an infinite object, well, it's kind of like a generator, into a finite collection. So now that it's a finite collection, it may be a collection, it may be a list, it may be a map, and then you can apply any other method that you already know from collections. You can use functional Java in the same way. I'm showing a couple of meta class tricks so that you can transform a functional Java function into, well, actually a Clojure into a functional Java function. This trick of using the as keyword will probably be gone by the next big version of Groovy, either it's 2.2 or 2.3, because that's by the same time that we will have some alignment with JDK 8 lambdas. That translation will be transparent. The moment that I posted these slides earlier in the year, this guy from Australia replied, "Hey, I'm already working in a module for functional Java and Groovy integration. There's the link to the GitHub homepage. He has released, I think it's 0.2 snapshot in the last month or last 2 months. So it's still pretty recent. Another thing, well, yeah, streams. Beware of streams. I believe that now the API is limited, is done. There is no possibility to do any changes for JDK 8. But I highly encourage you to try it out. If something can be changed, then we can do it, and we can make it happen for JDK 9. We have partial evaluation. That means you can fix a value of any argument to a specific data point. And what you're doing with currying, you transform a function from a certain number of arguments into a function that takes less arguments. Many people ask when encounter this feature, they say, hey, I can only curry from this end to the other. Can I do it from the other direction, or I can curry in the middle? Previously, you couldn't. Now you can. You can do rcurry, or you can do ncurry. You can also use objects at partial levels. And the key to do this is kind of like functions that that is stateful functions. The key to this is define a method whose name is call. That's the only trick. They can take as many arguments as you want, or 0 arguments, it doesn't matter. You have it. I have just 1 more minute. I can talk about composition. This is just calling a function and then calling another function. You can use this operator to call the add4 function first and then the mul function. If you want to do it the other side, use the other operator. There are a few other things that I can certainly show you, but my time is up. I will post these slides online. You can get access to the rest of the documentation and information. But my takeaway message for you guys is, please give this a try. Functional programming is here to stay on the JVM. Pretty much every other JVM language, other major JVM language supports functional programming. So let's get going. Let's do this. So thank you very much.